Hello everyone, and welcome back to a new episode of SHENZHEN I, joined again by Rose.
Hiya!
Hello, hello. And I think we are just going to get started here.
I love the weather report.
Yeah, so one thing I thought about doing at some point was I don't really have an intro for this series, and everyone on camera has heard this already before.
Okay.
I don't have an intro for this series really, and I never quite know what to do. And I thought maybe it would be interesting to try reading this out loud as part of the intro. And I did it once, and it just felt dumb, so I didn't do it.
That's okay.
That's all. So this is a pretty good solution. Seems like
it turned out we went back after we turned off the camera and took out a line of code.
No.
Yeah.
Oh, yes, right. You wanted to take out the line of code and, make some other changes to it, but that didn't work. Just taking out the line of code was the answer.
Yes.
Yes, so we did save, although I think it's gone, right? Because we also tried to edit it somehow. No, we put it back.
We put it back.
We just took out the line right here that was initializing this output to 100, because it turns out that the one, you always hit either one of these two in time, and so we didn't have to pre-initialize to 100. So we only needed 8 lines of code, not 9, but nothing else changed. Okay, so our next puzzle is traffic signal. So we're building a traffic signal proposed by Wu Lily. Once again, we are set to contribute to a piece of a larger system for a company controlled by Sun Haotian. This one is a traffic signal for a 6-way intersection with support for emergency transponders that override the normal traffic pattern. 6-way intersection! So I don't know what sinister purpose they're going to actually put this to, but it has nothing to do with the traffic control system, I can tell you that.
Oh, you don't necessarily know that.
Have you been part of any of the other...
I mean, you told me that they were sinister, but you didn't tell me anything past that.
They're just, you remember the one with the aquaponics?
Yeah, you told me about it, but I didn't actually read through it.
He's clearly a military contractor.
Alright.
We also built, although I think not for him, some sort of automatic carbine range-finding targeter.
Carbine range-finding targeter?
Carbine.
Carbine,
As in a rifle.
Indeed.
Alright, emergency here is a simple input connected to a device that detects the transponders in nearby emergency vehicles. Lights 0, 1, and 2 are simple outputs connected to go and no-go traffic signals for 3 different directions of a hexagonal intersection. Control of the lights should be sequenced as indicated in the verification tab, turning off all lights when an emergency vehicle is detected and restarting the sequence when it leaves transponder range. Okay, page 2. The duration of the phases are set by the operator using switches that can be read as XBus inputs. Okay, so
those are our duration phases.
Yeah. So we want to be in phase 1 for 5 bits, and then 4, and then 2. Okay.
Verification.
I have a little pictures in here. So, we're not getting an emergency thing. We're just timing. We turn on light 0 for, indeed, 5 cycles. Then we switch to light 1 for 4. We switch to light 2 for 2 signals. We go back to light 0, but then the emergency shows up, and when it's done, we start over at light 0. Okay. Seems pretty clearly defined.
Yeah. I don't know, I can't tell how sinister this is.
Yeah. No, I'm not sure how we do this, though.
Well, I mean,
Well, okay, so one thing that seems pretty clear is this.
Okay.
Right? I mean, we definitely just want one of these on at a time.
That's
which
fair.
is perfect for a muxer. Right?
Okay,
We don't want to
that's
spend
reasonable.
3 simple I/O on this. We want to spend 1 XBus.
That's fair.
So we also need to be able to jeez.
Can you just run the emergency signal through and something?
No, because when the emergency turns off, we need to start the signal over again.
Right, but I'm just wondering if that's a useful way to turn it off in the meantime.
I don't think so.
Okay.
So what state do we need to store? We need to know where we are in the cycle, and which light is on, and how much longer it should be on for. And those are like the only 2 bits of state we need, right?
Okay, so that's one big chip.
Yes.
I mean, I can probably write a chunk of that code, just off the dome piece, as it were.
Somebody's been watching too much Northern Lion recently.
Somebody's been watching too much Northern Lion. It's you. It's clearly you.
Yeah. So let's see. Parts we don't need are all of the stuff below here. And parts we do need are all the parts above there, so that's nice and easy. By the way, I don't know if you noticed, we have comments.
I see that. It's very nice.
Yeah, and they're just as limited in space as everything else.
No, if you need to comment longer than that, you've probably done something wrong.
Yeah, I've never had any reason to write a note at all. Like, I don't know.
Presumably it's what you're doing when you leave in the middle of solving a puzzle.
But they take up space.
No.
Right? You can't fit them on the chip. It's the worst.
That's terrible. Let's put in a chip, and I want to write what the inputs and outputs do.
Well, okay. So let's.
I want to write ignoring the. Oh, you can move those. That's nice.
Yeah. They were in a pretty inconvenient spot. So. I think both sides here are inputs we can read, so we can put them wherever. So, like, in theory...
So I want to ignore the emergency for now and come back to it.
Mm-hmm. Actually, I think we want them up top. The emergency part, I think, is kind of easy to write.
Sure. It's the interaction of the two, but that's...
Well, no, I would actually just... Like, the emergency part is so easy to write that I would write it first.
Okay, so write the emergency part.
Which is basically like, okay, we wire it up like so. The problem is, in order to write it, we have to figure out the data structures that we're using to encode the state that we're in, right?
Right. So we know which light we're on.
Yeah. So an obvious thing
is to put which light we're on in DAT.
Yeah, exactly. And how long it should be on in ACK.
I don't know that we've got the code space for that, but I have a simple solution if we don't.
Yeah.
I mean, there is... Well, it's not great. No, so let's not do that.
So let's wire these up, I guess, like...
In order.
In the optimistic way.
That's a B.
Thank you. So, like, this is the wiring diagram that would be ideal. If we could...
Right, you also need to stick something on emergency.
Yeah, if wishes were candy, like, this is what we would have, right?
Never heard anybody say if wishes were candy.
Yeah, it's a thing.
No.
Yeah, it is.
No, you're crazy. Nobody's ever said that.
Yeah, sorry. Well, I would go Google it, but that's not something I'm going to do on camera, so...
Moving right along.
I might have used it wrong, but it's definitely an idiom.
Okay.
So we've got everything wired up here, and that's all great. But, like, so let's imagine that we've got all the code space to do the stuff that we were talking about. How would we handle emergency? It's basically like this. Test equal P0 100, and if so, we move 0 to DAT, move 0 to ACK, and move 0 to X2, and jump to done. Like, that is a thing that definitely solves it, and I think kind of the only thing that you can do.
So you don't need to move 0 to ACK, because when we enter the 0 state, we're going to start by moving.
Disagree,
okay.
Because how will we know that we're not... So let's say we get to here.
Right.
And we're ACK started at 5, and then it was 4.
Right.
And then the emergency vehicle came along.
Uh-huh.
And we left the thing at 4.
Uh-huh.
Then we just did nothing else. And then we get to the end of this stage,
Uh-huh.
and we say, what phase are we in? Oh, phase 0, and there's 4 bits left. But that's not true. There are 5.
Right, so what you should move is not, in fact, 0 to ACK then, but rather the input that is currently on X0 to ACK. Or X3, I think, is what the one you want right now, as you've got this wired.
Okay, yeah, I think you're right. Instead of 0 to ACK, we will move X3?
Yeah, that's what you've got wired up right now.
Sure, that seems better. And then our done is just going to be like sleep 1. Now, what do we do with the rest of this stuff? Well, first we want to test whether ACK is 0, in which case we need to like add 1 to dat mod 3, which like that's right. That's the problem is we need to do math on dat, and we can't throw away the stuff in ACK. That's something that comes up all the time.
We don't need to do math on dat.
Okay.
Oh, I guess we do.
Yeah.
Okay.
So that comes up all the time, is that like I have enough registers, but they're not general purpose registers. I think we also don't have enough code space here, but you know, maybe we do.
So a simple modification is to do essentially what we did for the sandwich machine, which is to make it one piece's job, one chip's job to say which phase we're in, and the other chip's job to count down that phase. Since the obvious way to handle these phases, or at least the way that's obvious to me, is to just subtract 1 from ACK and sleep 1 until ACK is 0.
Right, and then when ACK is 0, you have to like...
Right, we send a signal back out to the other chip and say, give me my next phase, and it does.
Right, but which one of those two is responsible for the emergency? They kind of need both, don't they? They both need it, don't they?
Depends how you do it, right? So if we did, in fact, set up an AND gate for the emergency signal,
okay,
then we wouldn't, right? We just and not the input into our final nuxer.
Well, A, you can't do that because you can't and on XBus. Right? And is for things that are discrete, either 100 or 0.
Okay, well then that's not a solution.
Right. And I'm not sure exactly how you would coordinate that anyway, because the emergency thing could turn on for just a single cycle, during which time the guy whose job is counting down hasn't switched phases yet.
Sure.
So I don't know that that's really a big one.
Okay.
I think we do have to split it up into 2 chips. It's just not clear what the division of labor has to be. I like the idea of saying like, hey, you know, give me a countdown signal, but I'm not even sure how.
Well, okay, so let's just solve this as 2 separate pieces to start with, and then figure out how to make them work together.
All right, what pieces?
So grab me another chip, and let's just write the code. We'll hook things up later, but let's just write the code that would do the sleeping in order.
Does what? So what sleeping?
Okay, so here's what I want to do. I want to I'm going to talk this slightly higher level than I should, and then we'll work it out properly.
Okay.
But what I want to do is move. Well, this is 0. Is 0 100 or is it 1 on our muxer?
What? Neither.
Light 0.
They're all light 0. What do you mean light 0?
Go to the right. Which light do we turn on when we write 0/100? So that's 100.
When we write 0, we turn on none of them. That's why you're confused.
Right, sorry. 100 or 1?
Yeah, 100 is turning on light 0.
Okay, so let's move 100 onto pick an X bus.
So you want to just write that?
Yeah.
Okay. Fine.
And move X0.
X0.
Yep, we're gonna hook that one up later.
Okay.
Into A.
Okay.
Yeah, that's fine. I know. Okay.
What is going? So I don't want you to just start writing instructions and that you're dictating without me having some idea where this is going.
Sorry. So what I am doing is writing in isolation a chip whose job is to pass on signals to the lights in order for the right amount of time. And I'm currently making the assumption that the correct number is being passed to this chip, although that's not to this chip in a single location.
But how is this chip going to do it for the right amount of time?
Right, well that's what we want to write, right? Which is why we're moving X0, which is what's going to be on...
So you're going to connect this to all three of these guys.
Yeah.
But then there's no way for it to receive any input from this, and there's no way, right?
Well, we can use a P.
I don't...
Right, well, that's why so what I want to do right now is solve the two problems in isolation.
I don't think that's a good idea, because you can do that when you have the privilege of black boxes and any abstraction at all, and we don't.
Okay.
I think that we need to figure out how they're going to communicate. I think that's a hugely important part of building either one of them.
I agree it's hugely important. I just felt that it would make more sense to both of us to have written the algorithms to do the separate pieces first, and then figure out how to make them communicate.
No, I think it's... Because the problem is the algorithm with communication is completely different from the algorithm without communication.
Okay, that's fair.
Because you have to be able to be interrupted, and like that just makes everything else weird and not work.
Okay, that's fair.
So
here, well actually it's not that. So to bring this back. Okay, so here's what I want to do. What I want to do is have the chip on the left do the following two things.
Sure.
Give us 10, 1, or 100. To say which...
Give to this.
Yeah, give to that, 10, 1, or 100. For which light should be on. And also act as a switcher based on that for which thing should be going in the accumulator at this time. In other words, just forward straight along the correct accumulator along one
the correct accumulator?
So in other words, if we are currently passing 100, if light 0 is on, then this chip on the left just passes through whatever value passes. What I'm trying to do is construct a single chip that takes 3 inputs that are these 3 phase tickers and outputs one thing that is the count for the current phase ticker. And just leaves it as that constant number.
So, I think that the job you're giving to this thing is a little bit too complicated. I think, so, what appeals to me as a way to divide up the labor and to talk about the communication protocol between the chips is that there should be one chip that is wired up to these 3 things and the other chip, and nothing else.
Okay.
And its job is to receive a number on standard in, if you like. 0, 1, or 2. And output at least 2 things, maybe 3. One of them is what signal to write to this. One of them is how long to write it. And a third is what your new DAT should be. We'll do the math for them.
Why are you doing the math if you don't need to know what the new DAT should be if you already know what signal you're writing? So I just suggested exactly the same thing.
I disagree, because what I'm talking about is this guy needs to send the current value of DAT to say which input to be given. He says, we're in cycle 0, please give me the values for cycle 0. And if nobody ever tells, you can't get to 1 from there in the same chip because we don't have space to do math.
Yes, I agree. So I think that we're talking about 2 different levels of abstraction. I think that we are trying to solve the problem the same way and not agreeing despite that. or in a very similar way.
Okay.
So, choose a chip, left or right, that knows which phase we're in. Or do you think that they both need to know?
The chip on the left, the one who is talking to emergency,
Uh-huh.
knows the phase that we're in, but doesn't understand how to do anything based on that phase. He sends the phase to the other guy, who determines which phase comes next and sends it back, in addition to what we should do in the current phase. So I say, I have chip A, the main controller, who says, we're in phase 0. I need to know my outputs for phase 0, and what phase comes after 0. And those are the 3 responses he gets back from chip 2.
I see. So you want... Okay.
Because he's the guy who knows what phase we're in cannot do the math on it.
Right. I agree with your statement, but I wasn't trying to do any math.
Okay, but how are we getting the next phase? You were just saying, we'll just get the next phase, and we can't just do that. The guy who's got the emergency input has to be the one who knows what phase we're in, because he has to have the authority to set it back to 0.
Yes, but you don't have to do math to do it.
Not to set it to 0, but to roll it from 0 to 1, and from 1 to 2, and from 2 to 0, you do.
Okay, well actually I wanted to roll from 100 to 10 to 1.
Okay.
Because that reduces your load. Right now I don't have to send a different input, I just send what phase I'm in, and that is the output.
Okay. That seems good. It makes it, we can't just do math then, but I guess we couldn't really anyway.
Right, I mean, that was your whole argument, is we couldn't do math, and I'm saying let's not do math.
This chip can do math.
Sure, but we don't need to do math. We just need to know, if we're 100, switch it to 10. If we're in 10, switch it to 1. If we're in 1, switch it to 100.
Yeah. It's too bad we don't have it the opposite way, because then we could just say multiply by 10, and if it's 999, then set it to 1.
So wired the opposite way.
I can't.
Over on the
I see.
Right.
Of course I can. I can, okay. It's a little bit harder.
Sure, but if you're convinced that that's easier, let's do that.
Right, so we want 1 to be connected up to light 0 here. And these guys so. A bit convoluted. Let's see. Light. Which is the one? This is the one that needs to get to down here.
Yeah.
Wait, is it? Yeah, light 2.
That's how you got it set up.
The problem is I don't have another. I need another bridge, and I can't do it like that. So I have to.
That's not gonna work either. And it doesn't flip at all.
No. It flips the point this way.
Yeah, that's not helpful.
Yeah.
Okay.
Okay, so what?
So let's not do that.
No. We just have to make 1 more bit of space and we're fine.
Okay. I'm not sure that this is a win, but you seem happier with it, so let's go with that.
I think it makes it substantially. You have fewer branches, and it's just easier.
Okay. It's fine.
Okay, so we
want P2 connected to light 2.
Yeah, so this is the one that gets to go here.
Yep.
This one
goes to light 1.
Yeah. How exactly was more vertical space helping? Probably
Now you can go under.
Yes, like this.
Yeah.
Right? Wait.
But that doesn't work.
Dang it! Like that.
Yeah.
Oh, right. And we need the vertical space, the horizontal space, because we have to do this.
Yes.
To cross over.
Alright, so that's a goddamn mess.
It is.
But you are convinced that it makes our code simpler, so let's do it.
Yeah. What if we did something a little different and used this?
Sure.
And we put the numbers 100, 10, 1 in it, like, then we could just read the next state we should be in.
Yes, although, I mean, that's not necessarily a bad choice, but let's,
And then we wouldn't need to do this, right?
Right. I mean, it didn't bother me to do the branching, so you seem really.
I think code space is pretty important.
I mean, I don't disagree, but I suspect we have enough.
All right. So okay, so I like your plan of let's start in state 1, and then move to 10 and then 100.
Yes.
And use those as the inputs to the guy who tells you. Well, at that point, like, what is he telling you exactly? He's telling you, I guess, what the next state is, and also how long the current state is, but he doesn't tell you what to output for this state.
Right.
Because that is the state itself.
Yep.
Sure.
So my suggestion was, in fact, a slightly different division of labor, which is that one chip says what state we're in, and therefore which one of these phases we should read.
Okay.
And the other chip outputs and sleeps, and knows how to turn off when it's told to.
Being able to turn off when it's... Wait. What? So...
But maybe that's not a good solution. Like, so can we put a chip out? And I know that you don't just want me to dictate code, but I'm not sure how to describe this without dictating some code. So my suggestion is to... if ACK is 0, or P0 is 100, write 0.
To what, x2 or something?
Yeah, x2 or something.
Okay.
No, sorry. If P0 is 100, move 0 to x2, but not if ACK is 0. So, alright, leave this alone for a second. So, if P0 is 100, move 0 to x2.
If P0... I can't agree because I don't know where we're going.
I'm going to wire P0... I agree with myself. I'm going to wire P0 to the emergency. Okay, having passed that, if ACK is 0... leave it alone for now. We're going to want to jump around stuff. But if ACK is 0, move x1 to ACK. Otherwise, subtract 1 from ACK. And sleep 1. And in fact, it doesn't need to be an otherwise. You just do that. You sub 1 and sleep 1.
Okay.
So this is the chip that I was trying to suggest writing.
Okay, so let me see if I can describe what this chip is supposed to be doing.
Okay.
It's reading the emergency.
Uh-huh.
If that is true, then it moves 0 to x2, which is this muxer?
Yeah.
And then it tests whether the accumulator is 0, i.e. we are out of time
on the current one.
On the current phase. If so, it moves x1 into ACK, subtracts 1. Okay, so it's reading the next phase number.
Right. So at no point here did I actually read or transmit the current phase, which is I think where you've been trying to tell me I've been broken the whole time. And I just needed to see it in code. So the problem is, right, that we're doing the counting, but we aren't telling anything to turn on the right light. And I was suggesting that we could just do a simple pass-through. Which possibly we can still do, but maybe not. Right, this is just doing a sleep, but that's not helpful because at no point have we told anything that we are sleeping.
Yeah, well, so I think we're basically like, the thing that is in control of everything must be sleeping exactly 1 every cycle, and so everyone knows that.
Okay.
Right? That has to happen because it has to check emergency every cycle.
Agreed.
It can't do a sleep for any longer period of time than 1.
Agreed.
So the thing is, I just like this seems like backwards to me. It seems like you want the guy in charge of emergency to not be in charge of the light.
Okay.
Well, is that true? No. No. I guess like.
So the other thing that I actually wanted to do, let me. So if AC is 0, so let's also move X0 to DAT. So if AC is 0 plus X0 to DAT.
So that's our new output value?
Yeah. That's which phase we're in. And then we always move.
So what is X1 even? Like, what is that?
So what I wanted to do with X1 is make it a switch based on which phase is on. That gives us on 1 pin the values of all 3 of those.
Right.
And switches based on which phase we're on.
Right, but you can't just read X1. You're going to have to tell somebody on X1 to do a thing. You cannot just read X1.
Well, I can if there's a central controller.
But that's like, I don't think we need 3 chips.
Okay.
I think we need 1 chip that is in charge of watching this and counting down time and maintaining a state number.
Okay.
So let's copy this away so that sleep 1x. Let's copy this away so that you don't feel like I'm throwing. Whoops.
I mean, I've explained what I was trying to say, and you think that it is not valuable, so that's okay. I mean, you don't think that this is a solution to the problem,
right?
But I have now explained what I was trying to say, and I believe that you understand.
Right. So let's get rid of these, and what I'm envisioning is what a mess. Let's get rid of all this crap. Is one guy who is in charge of all of the I/O,
okay,
but is not in charge of these.
Okay.
So I don't know if we need a large chip or not, so we'll start with 1.
Okay.
And his output is to here.
Yep.
And he also talks to, I don't know if we can fit one of these guys in, so if we can afford to use just one of those guys, we'll use one of these.
Yep.
Scooch over, please. We'll wire these 2 up like so, and this one goes here, and this last one comes around to here.
Okay.
Okay. So this is the wiring diagram, I imagine.
Okay.
This is more of a nightmare than an imagination over on the right, but
no, we think it works.
Yeah. So the idea is that he I don't think we need to start with, well, okay, so he starts by putting the phase number into DAT. So let's, I don't know if we want to do this exactly, but move 1 into DAT.
Okay.
Maybe we can somehow avoid, maybe we can make 0 act the same way, I don't know.
Okay.
And then what we do is every cycle check test equal P0 100.
Uh-huh.
If so, then move 1 to DAT, move 0 to ACT. 0?
So I was going to suggest that we move 0 to DAT, and we use 0 in DAT as indicating that it's emergency time. And then every time we read that and it's 0, we can always switch to 1 next.
But we don't need DAT to know that it's emergency time. We can just look at P0 every time.
Yes, but we also need to communicate to that to some other chip.
No, I don't plan to.
Okay.
The only chip we're going to communicate it to is this one.
Okay. So you want to move 1 into that and then move...
So the idea is, like, move...
I don't think you need to move anything into ACK, but maybe I'm wrong.
No, we need to move 0 to X2 at least. Okay, now, what we're going to do... And, like, jump done. So we sort of... I described this already before. Done, sleep 1. Now the idea is test equal ACK 0.
Yeah.
If ACK is 0, I want to be done with the current phase. And therefore send this guy a message with the current phase. Move DAT to X3.
Okay.
And then receive back from him a new ACK and a new DAT.
Okay.
So I'm just going to move X3 to ACK. Oh, whoops. These should all be pluses only. And move X3 to DAT.
Okay. I see what you're saying.
Yeah.
Okay.
And so...
This is conceptually very simple, very similar to what I was trying to describe. But I think handles the way that these weird chips work better.
Right. So... And then
now you need to subtract 1 and sleep 1.
Well, we're not done.
Oh, right.
Because we need to...
move to DAT to X2.
Regardless of whether we did this, we now need to move DAT to X2. So here's an interesting point, is maybe you were right that we can just
right, well that's why I suggested it.
Use a 0, but the problem is, when we send this guy a 0...
It just knows that 1 is next.
But that's a little hard, because that's adding an extra clause in his switch case, right?
Alright, well...
Because it's not like we can add it to the same case as 1, because after 1 comes 10.
Sure.
So it needs to somehow be in the same state as 100, which is a little bit hard. So maybe we can do it, maybe we can't. But...
Yep, we'll figure it out later then.
So I think that's sort of the outline for this guy.
Okay.
Move 1 to
You
DAT.
need to subtract, you haven't subtracted yet.
Thank you. Sub 1. And then we're going to be done. Yeah, okay. So now here's this guy, and what does he do? Well, he sleeps for X3.
Yeah.
Moves X3 into, I think ACK is probably best, yes. And now we can just do a test equal on ACK for, let's start with 1, I suppose.
And if we're doing a test equal anyway, then there's no reason to do the wiring over on the right, because we can just start with 100 instead of having to start with 1. Finish writing this and you'll see why.
I don't...
Finish writing this, and then I'll make my argument.
Alright. If ACK is 1, then we move... Let's see, what order is he taking things? He's taking ACK first. We move X0 over X3 and move 10 over X... Well...
Over X3.
Let's not... I think we can do a little bit better. And let's do test equal ACK 10. If so, move X1 to X3. Test equal ACK 100.
Move X.
Yeah. X2, thank you, to X3. And now we can sort of do a mul by 10. And then a test. Yeah, this is going to be more code, isn't it?
Yep.
Okay, well, let's not do that then. So we'll just move, so in this case it was 1, move 10 to X3, move 100 to X3, move 1 to X3, 3.
And if we've been past 0, we also need to check for 0.
Why would we be past a 0?
Because that's what we did if move x3 dat.
No, that should...
Where's the... Oh, we moved 1, I see. But we are moving the current phase to get the next phase. So
yes.
We can't move 1 if it's 100. We need to move 100.
What?
So if we move 1 to dat...
In which chip? This one?
Yes. In
Okay.
this chip, if we move 1 to dat...
Yes.
So the emergency signal comes on.
Yes.
And we wait patiently.
Okay.
Now the emergency signal turns off.
Ah.
We have 0 in ACK.
That's what you're saying, right?
Yes.
Okay. I agree.
And you do need to put 0 in ACK as well in that phase.
Yes. Move 0 back. How are we doing in terms of code space? What do we have left? We have 1 slop. All right.
Well, I don't think you need any more.
It's very easy to be wrong about that guess. I have been wrong about that a lot of times. I've been like, okay, we have enough space, I'm not going to optimize. But you know what? Here's this one thing that's pretty... I can save 1 line. And then it turns out there's like 3 or 4 cases I've forgotten, and I needed that line.
Sure, sure. I think that you have now written a successful bit of code.
It looks that way, but I don't believe it. So we're going to step through here.
Okay.
Actually, I suspect that just stepping through, we're going to is not going to finish the first phase.
All right, well, we'll go through.
All right, so this guy's sleeping. Meanwhile, we start by moving 1 to dat. We're in phase 1. Okay.
Yep.
Test P0 for 100? No. Is ACK 0?
Yes.
Yes.
Oh, we need to move 100 into dat to start with.
Yep. Same thing as the emergency.
Yep.
ACK 0, yes. Therefore, go ahead and send this guy a thing. We say, I'm in state 100, where should I go? Is it 1? No. Is it 10? No. Is it 100? Yes. Here you go. So you should enter X.
You passed those in the wrong order up there.
I did.
So just switch them in the other one, because that'll be fast.
What are you talking about?
Switch them at the bottom, not the top.
Switch what at the...
Switch the order that you expect to receive your inputs, rather than the order that you send them in.
Oh!
So that you only have to switch in one place, not
Well,
2.
yeah, okay. I didn't understand what things you were saying were in the wrong order.
Now you have them
in a different order than I did.
No, you wanted ACK first and then dat. I was wrong. Just don't listen to anything I said. Yes, that is correct. Apologies.
Right. Okay. The problem is that this is wrong, right? That's what I was...
No, it's right.
No, it's not, because we don't want to... We're testing what the old state was and using that to determine what new state to send. That's what was wrong, not the other thing.
You are right.
So here we need to send X0. This needs to send X1, and this needs to send X2.
That is true.
Here's 100. What should I do next? Move X0, which I guess is 5?
Yeah.
Into ACK. And move 1, that's your new state, into DAT.
Yeah.
Now we move DAT to X2, writing a 1, and you're right, this whole thing is not useful since we're not multiplying.
Yep.
So we can fix all that. But we did turn on light 0.
Woohoo!
Okay.
Desire.
Yeah. Okay, so this switching is all working astonishingly well. Now let's see how we handle the emergencies.
Yep.
Is P0 100? Yes, therefore move 100 to DAT, saying that when we leave emergency, we should go back to light 1.
Yep.
Move
Light 0, but yes.
Yeah. Move a 0 to light 0, which is indicated by a state variable of 1.
Yes.
Move 0 to X2, turning off all the lights, and jump to done.
Where we sleep.
Great, and he's just going to do the same thing, resending that 0 every time. Fine. And now it's done, and we're back to the state where we were at the beginning of our thing, right?
Yeah.
Yeah, great. Okay. So let's fix this mess up.
Yep.
Because we didn't need it at all after all.
But it made you happy while we had it.
Yeah, because I imagined we might be able to do some multiplication. aesthetically pleasing about here.
As long as you're happy.
Uh-huh. Okay, and so here, we need to start...
We just reverse 1 and 100.
Yeah, all the places
we have 100, we change it to 1, and everywhere we have 1, we change it to 1.
This is the worst kind of refactoring I've ever heard of in my life. Let's turn this into 100. Can I turn this into 100?
No, don't make that 100.
Magic numbers abound!
Magic numbers abound!
Alright, but these are the only places where it matters here, and then we have to do the same thing up here.
Yes.
This 10 is the same, this is a 1, this is a 1, this is a 100, right?
Yes.
Did we miss any? Let's find out. Test it in prod! Alright, I think we did it.
Alright, so you can definitely... I think that you can save yourself a chip. We have less code, that's amusing. So I think that you can instead use a smaller chip for that bottom chip.
Really?
Yes, by, in fact, making the emergency signal be 0.
The emergency signal be 0.
Yep, and
what are
add
you
a
talking
case,
about?
So add a case at the, for the upper one to check for 0 as well, and then just handle 0 by moving 0 to dat.
So, I'm not sure exactly how that's going to work out, but I kind of see where you're going, so I'm happy to accept dictation.
Okay,
So
well, I don't actually know, but, so we don't need to do that. We don't even need to add a whole new case, right? We can just use, so if we're at 1, where's my test for 1? The last test, right?
Mm-hmm.
Or we're at 0, so just a minus TEQ at 0.
Okay.
That will work.
Okay.
Right? Am I wrong?
So you're saying if we're in state 0,
Uh-huh.
to behave as the same as we would if state 1 were ending.
Yep.
Alright. Yeah, this seems productive. I'm not sure exactly what changes we have to make here. First thing is this.
Don't need that. Yep.
If so, we're moving
0 to dat.
0. Well, are we even...
We still
Yeah.
need to move 0 to dat.
But not AC, or...
We do need to move 0 to AC.
No, because we're about to send this guy a signal, right?
No, we aren't going to send that guy a signal yet, so we want to move 0 to AC. You're going to be happy if we move 0 to AC.
Okay.
We don't need to move 0 to X2.
Okay.
And now done needs to be at the move dat and then
What?
sleep one. So
Oh, you want to move the label.
Yeah. And I want to move the sub one so that it's above that label.
Like that.
Like that.
So, okay, we're saying if P0 is 100, we move 0 to AC and DAT, and then we're done.
Mm-hmm.
We move DAT to X2. Now, blah, blah, blah. Now, if it turns out none of that was true, we see if AC was 0, and if so, we ask the guy where to go next. Yes, I think that works. It has not saved us
A chip yet.
a chip yet. We need to shave off 2 more lines.
2 more, okay. Well, if we can figure out how to get rid of the move and the jump, that would do it. That one.
These two?
Yeah. I don't know if we can, I'm just observing.
Well, first of all, does it still work? Yes. Okay. So that's a nice little savings, I suppose.
Yeah. Just a touch, anyway.
It added 1 line here in exchange for 2 here?
Yeah.
Alright.
It's not apparent to me how to do any better than that. Not immediately.
So, can we avoid this jump by putting ourselves into a state where all the stuff we want to do is harmless? And I think the answer to that is yes.
Okay.
By writing this. Right? That gets us to the same state. And now we don't need the label anymore.
Okay.
Now we're down to 10 bytes. We need to make 9.
Stuff will have gotten written to X3 that we are now not rewritten. Or won't have been written to X3. Oh, no, that's still okay, right?
Yeah.
Yes. Okay.
Right, this still works.
I think so. Yeah, no, you're right.
So that was 1 byte.
Yeah. We need one more line.
Mm-hmm.
I don't see how to get another line out.
Yeah. And this is probably sucking up more power? Well, maybe not, actually. Because we're doing one more test, but and one more sub. But we're doing one less jump. I don't know. I guess it is a bit more power.
So, here's an interesting question. We're moving DAT to X3 and then X3 to DAT.
Mm-hmm.
Oh no, never mind. I was thinking we were doing it the other way around.
No, this is, we're sending DAT and then we're reading a new DAT in.
Yep. No, that clearly needs to happen as we currently have things written.
Do we have... We don't have another X bus.
For where? Oh, up there?
Yeah, because if we did, this guy could be the one who writes out to the light. Well, except he can't in the case of 0. Could he?
Sure he could.
Well...
Oh, I see, but no.
Then we'd have to unfold these 2 cases, right?
Yeah. Someone is at this instant screaming at the YouTube video something really obvious we're missing.
I don't get enough viewers that I think that it's likely that one of them sees a way to fix this that is correct.
Well, okay.
There are a number of people who have seen a way to fix this, and I don't know that any of them are correct.
Well, they might be shouting at the screen regardless.
Yeah. But it doesn't bother me as long as they're wrong.
Oh my god, you're such a jerk.
Alright, so let's try to think about this a little bit of, like, not exactly from first principles, but describe each of these operations and whether we think they are absolutely mandatory.
Okay.
So, testing P0 for 100.
Is the emergency signal on?
Seems important.
Seems pretty mandatory.
But, you know, maybe we can somehow work in some kind of AND gate thing you were thinking about. Maybe.
Sure. Or another thing that we could do is we could make it the top chip's job to test the emergency signal. But I think that's a bad idea.
How would he even do that?
I don't know. No, I don't think it's a good idea. I was trying to think of a way and nothing was happening.
Right, because he only gets a signal.
Mm-hmm.
He sleeps until the other guy knows it's time for a thing.
No, as we've designed this, that's a bad choice.
Yeah. Alright, so it seems like we need the first line.
Okay.
If it was 100, 0 to DAT, 1 to ACK.
It would be nice if we didn't have to move 1 to ACK.
Or, rather, if we could avoid moving 0 to DAT. What if, And
we could move something else to X3 instead.
Yeah, exactly. What if we just wrote, like... if we here wrote directly to X3 rather than messing with our ACK and DAT in order to reuse this code. What if we made this code be basically
Hang on, I've got a better thought.
All right.
Instead of moving 1 to ACK. Sorry.
Can you point at the screen that I can see?
Sorry,
Thank you.
sorry. Instead of moving 1 to ACK here.
Yeah.
Why don't we just make the test equal on ACK being 0 be a minus test? what does that do for us?
Ah. Aha. Yes, we can avoid doing this, fall through into here, then if either P0 was 100 or dat was 0, wait. Yeah, so first we're going to move 0 to dat. So if either P0 was 100 or AC was 0, then we'll reset all these things. I think that does it.
Okay.
Oh no!
That is not a success.
Disaster. What happened? We're shifted by 1 somehow.
Well, and we also got something else wrong.
Did we?
Yeah. We failed on the emergency. Because if we're passing 0, we are still getting that back out. Right, so we pass at 0 up top, and now it's giving us turn on light 1.
Ah.
Light 0, whatever it is. So that does not work.
It seemed so good.
I love it, and I think that
I don't understand why it didn't work.
Do I need to walk you through it?
I guess.
Okay, so what happens is if we put 0 on dat,
yeah,
and we then pass x3 up here,
yeah,
it's going to give us.
So it sounds like the only change we need to make is this, right?
No.
Because then we'll actually... Oh no, we'll still get back a 1, won't we?
Yeah, so we never get back an emergency signal from this one. So now what we could do is have it automatically give us an emergency signal, but then it becomes messy in other ways. So that's why I was suggesting moving the testing of the emergency signal up here, but I think that's a problem for other reasons.
Right. So what if we, like, we send this guy a 0, like we were talking about. Well, okay, so first, how did we end up both getting the emergency wrong and being shifted somehow? Whoa, wait, what the fuck is going on?
I'm not sure.
What did I do? Oh, I know, I forgot.
Yeah,
we made this a minus, yeah. That was pretty nuts. Don't do traffic on drugs.
No, don't do traffic on drugs.
So everything is great so far, and then we get this.
Broken, so totally ignore the emergency.
But something else was wrong, wasn't it?
It did seem to be. We switched 1 too soon here.
Ah, because we probably are...
I've already subtracted 1 because we...
Yeah. So... Right, he gives us back...
Yeah.
So we have space in here for special handling for 0, right? Like, that's...
we think we have special handling for 0.
We have space for a special 0, so let's try that, right?
Okay.
We'll actually pass a 0 to this guy, and he'll say test equal act 0. If so, move... what are we writing
first? Tell you what you're about to break. You're never going to leave the emergency state.
Okay. Move 1 to x3. And move 0 to x3?
Yeah.
I see what you mean. Because... Yeah. Well, yeah. Because when we send him, we tell him it's an emergency now.
You're telling him 2 different things. You're telling him it was an emergency, and now you're also telling him it's an emergency.
Yeah, this isn't going to work. All right. I think we'll just leave it working as is.
Okay. You've got less code than you had, so you should run it all the way through.
Yeah. And we just...
yeah, you need to move 1 to add.
Like so.
Yep. I agree it's unsatisfying.
We have less code, but I think more power.
Maybe.
380.
I think this is less power, but I don't know.
No, it's more, right? Now it's 399. Previous was 380.
Okay.
Well,
let's go.
Yeah. All right. Well, that's going to do it for this puzzle. Let's see what they have to say about it. Oh, yeah, so many new emails. Cool Dad is back. All right. No yellow signal. Does that mean they're expecting robocars only? I wonder where they'd use this. We shouldn't speculate. It's our job to provide well-engineered solutions, not play detective with a client's overall plans.
I mean, I agree, it's sinister. I just don't know what the sinisterness is.
He's like, I don't know. Man, there's so many puzzles, like...
Meat-based printer is terrifying.
Yeah, I saw about that one in the specs. Let's go show you that for a second.
Are we continuing to record?
Yeah, but I want to look at the meat-based printer.
Okay, let's look at the meat-based printer.
Meat? I remember there was meat.
Awesome.
The assembled meat printer. So you have to, like, I don't know, somehow draw pictures and, like, assemble... This is one kind of meat you can make. This is bacon meat.
Okay.
One of them is, like, you know, right? Like, this is steak meat, cutlet meat, and you have to, like, somehow...
That makes sense, right? You're mixing the lean and the fat. That makes...
Yep.
I mean, this is more or less how 3D printing works. That's not even a lie.
Yeah. All right. So that's I think what we have to look forward to. It just made me smile. But that is definitely not in this episode for sure. So thanks for watching, everyone, and I'll see you next time.